Phylogeny and systematics, round 2. So in case you are better at mental math than I am, the answer to the last one was 2,000 years. If you have base pair mutations of about 5 base pairs per 100 years, and you're 100 base pairs different, that's about 2,000 years since they were last interbreeding as a single population, and they have now diverged into 2 species. So now what we can take a look at is comparative genetics with actual DNA sequences. I've made up some sequences here for 7 different organisms just to illustrate this point. And again, the more similar 2 organisms have their DNA be, the more closely related they should be on the tree of life. And so how would you actually analyze this DNA here to achieve any sort of relationships between these organisms? Well, the first thing that you want to do is make a consensus sequence. The way you make a consensus sequence is you take a look at the first base of all of the organisms and you figure out what the most common answer is to the question. So for this first one, G. The consensus sequence first letter is G. Pause this video and on your page, go ahead and complete the rest of these base pairs, looking again down the same line for any of these organisms, base pairs, and figuring out what the most common answer is. That's going to give you a consensus sequence. So pause the video now. Okay, hope you paused the video. If you didn't, shame on you. The consensus sequence is this: GAC, ACT, TAC, TAG. So then what you can do is you can count the differences that each of these organisms has from the consensus sequence. So for instance, looking at the perch and seeing how many different times the perch's genetic sequence differs from the consensus sequence. And I would suggest you just go ahead and write those differences over here. So pause the video, count up the differences, do that now. Do that now. If you didn't, shame on you. Here are the differences. So the mouse and the chimp both have 1 difference from the consensus sequence. The salamander has 5, and so on. So you can use these differences to achieve a basic phylogeny. But first, we're going to take a look at these organisms themselves. They each have traits, some of which are homologous structures, and so what you can do is you can look at these 7 organisms in relation to a few traits. The jaws, if they have lungs, if they have claws or nails, if they have fur or feathers, and if they have mammary glands. The idea here is that if their ancient ancestor had these, they should have them too. So if you make a table with a row for each of these organisms and a column for each of these 5 structures, we can start to check them off for the presence or absence of these structures. So go ahead, looking at the pictures and doing your best based on prior knowledge, have a chimp column, and then for each of these 5 categories, check off the chimp whether or not it has each of those. And what you should find will reveal, again, a phylogenetic relationship. Do that now. If you didn't pause the video and do it, shame on you. So here's what mine looks like. We can go through a couple of these. For instance, a pigeon, yes, it has a jaw. No, it does not have mammary glands. It does have feathers, it does have claws or nails, and it does have lungs. The hagfish, on the other hand, does not have a jaw, it doesn't have mammary glands, fur or feathers, claws or nails, or even lungs. So it doesn't have any of the features that we've been looking at. Now, if you were to try to arrange these organisms on this basic phylogeny, showing where each of them would sort of be related to one another, how would you do it? Again, the idea is that if at some point something like a jaw pops up, all of the organisms afterwards should have that jaw, but none of the organisms before it should have that jaw. So, make a hypothesis, test it out, put these organisms on this tree of life in the order that you think that they should be represented based on both their DNA sequence from earlier and the presence or absence of the structures that we were looking at up here. Pause the video, do that now, do it. Don't make me say shame on you.